Hello everybody, this is Dr. G. In this video, we are going to go over 2019 for response question number 6. This problem is a sequence and series problem. Let's have a look at this problem. A function f has derivatives of all orders for all real numbers of x. And all the derivatives are given here. A portion of the graph of f is above, along with the line tangent to the graph at x equals 0. Select the derivative of f as 0 are given in the table above. Part A. Write the third degree Taylor polynomial for f about x equals 0. So x equals 0, this is our center, c equals 0. For part A, Taylor series at center equals 0. F of x approximately equals f0 plus f prime 0 times x plus second derivative x squared plus third derivative. So third degree, we can stop right here, and all the derivatives are given by the table here. So we just need to plug it in. So f of 0, based on the graph, f of 0 equals 3. And f prime, the derivative at 0, because the tangent line is given, we can use the slope of the tangent line. So from 0, 3 to 1, 1. So the slope is given by rise over run. So it's -2 over 1. Plus second derivative. When n equals 2, the second derivative is given by 3. And the third derivative is -23 over 2 divided by 6 x cubed. Let's simplify a little bit. It will be 3 minus 2x plus 3 over 2 x squared minus 23 over 12 x cubed. So this is our final answer for part 1. B. Write the first 3 non-zero terms for Maclaurin series for e to the x. So we learned before e to the x, Maclaurin series, that means center is also 0. E to the x equals 1 plus x squared over 2 factorial. Write a second degree Taylor polynomial for e to the x times f of x at 0. So now we are looking for e to the x times f of x. Let's just copy everything down. Times 3 minus 2x plus 3 over 2x squared minus. We are looking for the second degree Taylor polynomial. We just need to keep x squared. We don't have to go any further. So now we just multiply these two polynomials. How do we multiply them? We can multiply 1 to each number. We'll get 3 minus 2x plus 3 over 2 x squared. X cubed, we don't have to multiply. X multiply each term. So x times 3 give us 3x. And x times -2x give us minus 2x squared. X squared over 2 times 3 give us 3x squared over 2. And we add all the numbers here. We have 3 plus x squared. This will be our final answer, 3 plus x squared. Part C. Let h be the function defined by h of x equals 0 to x ft dt. Use the Taylor polynomial found in part A to find approximation for h of 1. So part C, h of 1 equals 0 to 1 ft dt. So from the first part, this is our fx. Zero to 1, ft will be 3 minus 2t plus 3 over 2 t squared minus 23 over 12 t cubed. So now we just need to integrate each term. And apply the boundaries there. Now we can plug 1, 0 in. We'll have 3 minus 1 plus 1 half minus 23 over 48. You can leave your answer like this. You don't have to simplify it. You'll get full credit also. So this is part C. Part D. It's known that Maclaurin theory for H converges to H of x for all real numbers. Also, for H of 1, it's an alternating in sign and decrease, so that means H of 1 also converges. Use the alternating theory arrow bound to show the approximation found in part C differs from H of 1 by at most 0.45. So part D, we are looking for the alternating series arrow bound. So if you look at part C, we use the first 3 terms. So alternating series arrow bound is given by the next term. So if we are trying to approximate H of 1, the arrow bound will be given 0 to 1, the next term, which is 54 divided by 4 factorial t to the 4th dt. We plug everything in, so 54 over 4 factorial times 5 t to the 5th power, 0 to 1. So to save time, don't multiply them. So we plug 1, 0 in, we get 54 over 4 factorial times 5. We just need to write it out. 4, 3, 2, 1, 5. 54 times 2, we get 27. 27 times divided by 3, we get 9. So 9 over 20, which gives us 0.45. So based on the arrow bound, the approximation minus H of 1 will be less or equal to 0.45. Exactly, that's what we need. Let's have a look at the rubrics. So part A, 2 points, B, 2 points. 2 points here, and 3 points, last part. For part A, if you have 2 terms, you have 1 point. If you have the rest, you have another point. For part B, this e to the x is 1 point, and multiplication, 1 point. For part C, antiderivative, 1 point, and your answer, 1 point. For part D, alternating series arrow bound, next term, 1 point. Take the antiderivative, 1 point. And the final answer, which your arrow bound, 0.45, that's 1 point.